In example 4, we have a table that is displaying a function that we need to determine as to whether or not it is linear or nonlinear. As always, on a table, the left side has x values and thus will show a change in them. And the right side of your table has the y values and thus will show a change in the y values. Moving from row 1 to row 2, on the y side of the table, to go from 15 to 8. What do? You subtract. How much? 7. 15 minus 7 is 8. On the left side of the table, to go from row 1 to row 2, if you start at -2 and you move up to +1, then you have added 3. So you may need to use the calculator to help you or a number line to help you, but -2 plus 3 is +1. So now let's find out what this ratio of movement and behavior is. The change in y values was -7. The change in x values was +3. If you try to reduce that, you're not going to go real far, real fast. It does not reduce. So now for the second half of the work, to go from 8 to 6 in row 2 to row 3, we see that you have again subtracted, but this time by 2. And on the left side of the table, to go from row 2 to row 3, we have again moved in a positive movement, as 1 to 4 means that you had to add 3. So 1 plus 3 gives you 4. Our change in y values versus our change in x values. Our change in y was a -2. Our change in x values was a +3. And again, if you try to reduce this, you're not going to go real far, real fast, as 2/3 does not reduce. Now that we've done all the work, let's get an answer. So we have -7/3 for the movement from the first row to the second row. And we have -2/3 from the movement of the second row to the third row. And you know, and I know, that -7/3 and -2/3 are not equal. So we can determine that this table shows a nonlinear movement from row to row because our slopes, as the case will be, this change is not the same. It is not consistent. And there you go.